Good morning, friends. Esteemed Padma Shri Dr. Kota Harinaran sir, Director General Aero Siddiqui Saab, Chief Executive Semilac Prashaji, Director RADA Jadhav ji, Director LRD, Director DIL, our FPMT, all the Indian Air Force out here, all the users, all the designers, all the developers, industries, startups, and all the dreamers for the great India. My heartiest congratulations to C. Semilac and the entire team for organizing this one-day workshop. And in fact, I must confess at the outset that it has been a great honor, sir, to share the dais with none other than Dr. Kota Harinaran, who has been my mentor, guru, and been always with me. And thank you so much for giving India those great LCA firepower. Incidentally, when I came here in the morning and met all the heroes of aeronautics and the hawks in the sky, I really got confused where I am and what to speak. I candidly confessed in front of the organizers that it's a struggle, where C. Semilac says, yes, as much you practice in the trials, when it comes lawball, the shuttle does not cross the net. I confess so don't worry if the shuttle does not cross. Don't look at the shuttle. Look at the net and look at the sky. Friends, it's a great moment for our country, India. We are a great force, a force on the recon, a force to look at. India is not the India what was in the yesteryears. Today, India is at the inflection point of economy. India is the inflection point of technology, and India is in a great metamorphosis. It's the India which every country envisaged. It's the India which the whole world look up to. Why I'm saying all this? It's only because I made one statement one day that Indians are rocking the world. If you look at the United States, probably all the leading chiefs are Indians. So it's all along that Indians are rocking the Silicon Valley, Indians are rocking the sky, Indians are rocking the world, when India is going to rock the world and when India is going to shake the world. I think, friends, this transformation has come. Now it's the India which is rocking, and it's the India which is looked up to by others. And having said so, it's a great responsibility on every single Indian to live up to the expectation of India, to really make it rock the entire world. I was thinking to touch something here, but when I looked at C. Semilac's address, I read in the agenda that it's a welcome address. Unknowingly, he converted into the chief guest address. So I really forgot what need to say, but thank you so much that you made my job so simple that I had the liberty to skip few of the slides. But at the same time, having said so much about India, let me say something about DRDO. Friends, so much is talked about, and DRDO is undergoing a great metamorphosis today. DRDO is the defense force to reckon in technology. DRDO has been the force who has developed technologies for the new India, for the new defense power. It's the technology of DRDO which goes into the product goes into the system, and system becomes system of systems, and which becomes the force to reckon with, whether it is the deep sea, sea, surface, submarine, all up to the space. It has been the mandate of DRDO to develop technology. It has been the mandate of DRDO to transform technologies to the products, and the products to empower our armed forces. But at the same time, friends, a lot has been talked about technology, a lot has been talked about the systems. But if you look at C. Semilac's slides, as much we take time in designing a system, as much we talk about developing a system, a lot happens in delivering a system. So it's the time for the India to look at what is that gap between developing and delivering. And this is the gap probably which is going to be addressed in today's conference, that we may be the greatest developers. And that's probably the reason the Indians are shining in Silicon Valley, because they design and develop. But when I said my first point, if India has to shine today as a reckoning force in the world, it is this developing has to be transformed to delivering. Delivering to our armed forces, delivering through our industries to the country, and delivering to the rest of the world, which is most important, and it is an economic force to reckon. India, we talk about as a great economy, largest economy, upside down making Germany in few years and Japan next, and probably we are going to in the next years to come to the $10 trillion economy. This can never happen by consuming your own products. This can only happen when your product is the object of desire of the rest of the world. And this can happen, friends, not by developing alone. This can happen by delivering. Which means we have to have a great test facilities. We have to have a design for testability. We have to have a design for modernization. We have to have a design for maintainability. We have a design for dependence. And we have a design for trust. That a product which is designed by India is trusted by the users, trusted by the world. Today, we talk so much about weapon systems, we talk so much about Atmanirbhar Bharat, we still hold Samsung and Apple phone in our hand. The reason is what? Because we trust. We trust that this is the product which is going to connect me. This is the product which is going to make my WhatsApp faster. This is the product which I can communicate. Friends, for a mere communication device for the laser, if our hand is filled with abroad, how do we think our armed forces are going to trust on an Indian product where they not only fight for win, they fight for the prestige of the country. They fight to make all of us to be the superpowers in the world. That's the difference which all of us have to think of. That's the difference probably why this August gathering is here. And that's the difference. This day is going to make a transformation in the question which I raised from a developer to a deliverable systems. I think with this, for the next few minutes, I'd like to touch upon, I don't love much of the slides. There's some of them I was drafting in the morning in my office. Apology if there is any mistakes. What do we need the state-of-the-art systems for? It's the ever-increasing user requirements, because user is handling a dynamic network-centric warfare where every minute the design changes. Every minute the dynamism changes. We can question that the QR is something and the changes are coming in the product. Yes, it may lead to the delay in delivery, but let us deliver the system which is the state of the art, because user has every right to ask us for every changing demand of the system. That's the reason I say about the increasing user demands, dynamically changing threat scenarios, increased volume data available. This is very important where MSDF and all that we talk about. The external threat environment, which is continuously changing. Yes, there is an ever-growing need for the new technology. How much of it we use or not, but we all have to have it, because the today's war is not the war of contact. Today's war is the war of technology. Those who have got the highest. Today we say we have got F-35, we have got F-37. Whether F-37 is ever required to be used or not, but the holder of that, the designer of that, the producer of that becomes the world number one in winning of the war. So that's the reason you have to have a complete control over the technology. Anti-access and the area denial concept A2AD, all of you know about it, and a highly sophisticated integrated air defense systems. Just to give a quick glimpse of the fighter powers across the globe, United States leads with 1,854 fighters, where India is at 606, thanks to our LCA, AMCA, TEDBF coming up soon to fill that 42 squadron requirements. But still, it's a great thing to know that India is the third strongest air power today with regard to modernization, attack power, defense capability, and we are at the top 5 military powers. These are the statistics. What is the 4D power of the fighters? Advanced airborne systems to locate the threat. This is most important. Probably this is where I come from for the fighter aircrafts. Anti-radiation missiles, guided bombs and cruise missiles to destroy them. Electronic countermeasures to jam them, and stealth technology to evade them. As long as you have all these 4 dimensions, you are the true hawk in the sky. And which are the critical features? The air engagement of the dogfight, actually this has nothing to do with the maneuverability. And dogfight is one of the most critical thing on a fighter win. And it is about how strong is the situation awareness, how precise is your weapon systems. If you look at one example of F-35 today, it has got the most capable sensors in IR spectrum. Why I talk about IR spectrum? This has absolutely passive cool sensors. You can't radiate, you don't have to radiate. At the moment you radiate, you open up. You get detected, you are subjectable to the detections and attack. And much small magnitude of the RCS, this is what is the stealth. We talk about the long range detection, because the whole fight is who wins is who detects fast. Long range of detections, pilot would have the ability to exploit the blind spot and sneak close to him. It's with AWACS support, off-board sight missile power, and the most important is distributed aperture system with search, track, and attack capability across 360 degrees. This is what makes probably one of the fighter powers F-35 invincible. Fifth generation fighters, all of you know about network-centric combat, very low all-aspect multispectral signature, making it absolutely stealth. AES radars, IRST, VHSIC, high resistance to countermeasures, and so on and so forth. What is the fighter next? If all these we have today, we have to look for unmanned fighter technologies, because the day is not far where no fighter will ever live to be flying by the pilots. Solar power UAV is already developed, dual use optionally manned aircrafts, unmanned aircrafts, X-47Bs of Northrop Grumman I was going through. It's already taking off and landing on its own. Autonomous mid-air refueling. This is the world today. We have already reached there as a world in the technology. Lockheed Martin's U-class drone, Sea Ghost we call it. It's a stealth bomber of 1,000 pounds. F4 and F-16 is already remotely firing. That's what leads a multinational Delta Wing UCAV, Mirage 2000 class. UK has a supersonic autonomous stealth bomber, SWAV. JSF could be the last fighter and bomber. After that, we are all going to go under the world of entire autonomous warfare. This is what is going to be the future of the fire today. Friends, just to give a glimpse of what it is, all the mission sensors and payload, which I said that if you really want to be a firepower in the sky, that the body would be made by the aircraft, but the soul has to be with all the sensors. And a body has no value without a soul. And all that has to happen when you have got such class of systems here, whether AES radars, electro-optical tracking, infrared search and track, missile approach warning, distributed approach systems, very strong data link. This is going to be, communication is going to win the war, let me tell you. You can be having the most powerful sensors on the sky, but like I said, the network-centric systems coming up, the remotely operated fighter aircrafts coming up, if your communication does not have a huge bandwidth, huge data rate, absolute encryption, jamming resistance, you are nowhere. So that's going to be the next level of winning the war is going to be the communication, radar warning systems, ESMs, and the most important is MSDF, sensor fusion. If all these you have, you are invincible in the blue sky. I was taking just a global scenario journey, whether you talk about F-35, whether you talk about J-20, you talk about Su-57, one of the latest in Russia, and of course our Tejas, which is roaring further to AMCA and further back to the all futuristic technologies. And just I wanted to depict one of the war scenarios. This is how the world is going to be in future. And you can see very clearly here, apart from the aircrafts and the sensors, how strong is going to be the communication network to make that interoperability one of the best. Friends, all of you know we have got the AES radar Uttam. This is something I got about an APG-81 of the US. And if you see that, the features we have tried to compare both the radar and ESM systems, because it's a time for all my designers, they are all here, they are listening to me, that we have to not only match the international power, because somewhere in my address I said, chasers cannot be the winners. If we look at what US has done, if you look at what Europe has done, then we'll keep on looking at. You have to really look at what you can do, what you can design, what you can develop, and what you can deliver. I think Indians can do one of the best. And as long as you trust in your ability, as long as you trust in your design, as long as you trust in your infrastructure, I think you will be the world leader. This is just to give you a glimpse of where we are as compared to the world. If you look at F-35 electro-optics, this is going to be the next generation fighter inducted today, because we don't have the liberty of radiating so much in the sky. So we may be the stealth, but our radiation is going to pull all radiations missiles in to make it as a victim. So we have to depend more and more on the passive sensors development and passive synchronization. That's where the story of distributed aperture system comes in, wherein you have got IRSTs all around. You know very well this missile approach warning system is fantastic. It covers 360 degrees, but the range is very less. It goes to man-part class of missiles. So we have to go to transform IRST and MOS together to say something called the distributed aperture systems, wherein it gives a thorough coverage to the entire aircrafts, and also we achieve the range. In a few minutes back I told you, earlier the fighter detects, he can maneuver, he can counterattack, he can win, and he can save himself. So range is the winning. That's the reason 360 degree of a complete coverage with HMDS along with a long range of beyond 100 kilometers is what is going through the passive power is going to be the winner in the sky. And the last one comes out to be communication, navigation and identification system. This is again another very important component in the fighter, integrating it to the ground networks and providing all ability to share the details for the distributed processing systems, for the data analysis and MSDF. Friends, this is where I thought with this small journey of the world and where the technology is today, let's look at where are we today. I'll take a few minutes to speak it about. When we talk about airborne radars, yes, we have done long range primary radar, AEWNC, thanks to LRD and all the teams members, DLRL, everybody. AEWC Mark II is what we are almost ready and we are going ahead for this programs. Medium range for the maritime patrol radar, these are all for surveillance. When it comes to the fire control applications, all of you know about Uttam, which has been roaring in the sky for years, and now it is really going ahead very fast inductions because we have achieved all the major milestones which are required. Having completed this, we are already ready with Virupaksha, which is going for Su-30. I think a lot of news items are coming out of it. When the Su-30 upgrade is going on, thanks to Indian Air Force for trusting us, trusting our Indian industries, that they have bestowed the confidence that we are going to take on. And this is going to be another beast in the sky. When we talk about having done Uttam, the whole item has to be much, much bigger, looking at a far bigger range. And now we say the whole concept of AESA radar is the beam will move, the radar will not move. But today the system has changed. Beam also moves, radar also moves, because everybody wants the best of everything to have it on the aircraft. And that's why my team is all geared up to develop Virupaksha, that is for the Su-30 aircraft AESA radar. Then the series is endless. MiG-29, LCA Mark II, AMCAT, 8BF, and the list grows. So that's the kind of a thing. Of course, for imaging, we are going ahead with synthetic aperture radar for UAV. These what are the various operational mode. You all know that. I am not here to teach you radars. I'll just give you a glimpse. When we say that having designed a radar, why we take so much of time to test everything before we complete and hand over, because no industry will take up a half-baked product. No user will ever be happy unless every single feature is proven. You also, when buy a simple cell phone or buy a TV, in the shop you check every single feature, whether you use or you don't use. So that's the reason we have to show each of our features. So all of these modes, we have covered many of them, and we are ready to cover the rest of it, and that is what takes time. Friends, if you look at technology, a radar has come just like that. It has come with a series of technology. If you look at software-driven radar, that's the most important. Like everywhere is a software-driven architecture today. Multifunction, multimode. We have S-band, X-band, Ku-band antenna array. We have from LDMOS to GAS to GAN. We had a huge journey when you come to the TRM technology. Multi-channel receivers, a series of proven algorithms. As you know, Indians are one of the best in this. So we have got one of the highest firepower software inside the Uttam. And these are lots and lots of technologies which have developed, whether you talk about the array, we talk about the flight over the AAAU, we do the soft testing, qualification, then we test it on the flight bed, we see Semilak has shown, and then we look at for the final platform. So these are the 4 series, and probably today we are addressing this gap between this third and the fourth, and how fast we can bridge this. This is a huge set of technologies which radars are working with: plank level, tyke level, panel level array, whether gas, GAN, phase shifter technology. I think over the years, a huge has happened. And really when we compare it with our contemporary radars, we have done a comparison. I'll make a short, this is also one of the radars, RB2 for AESA radar for the Rafale. We have done a comparison with that also. And if you look at it, yes, this slide is very important. When we look at the AESA radar fighter platforms, the range performance with respect to the power aperture, Indian radar is one of the best in the world today. It has the lower weight, state-of-the-art hardware, and the fully software-controlled radar. Yes, we still need to improve on these points: in-band EW, NCTR, sensor data fusion, and better SAR imaging resolutions. Not that we are not doing it. This is what has been proven. This is what is on the designer's desk. So when you get also this. Yeah, this is one small slide. I'll take a minute to show. So much we talk about what DRDO is doing, what industry is doing, what DRDO is doing should industry do, and what industry is doing should DRDO not do. I want to assure all my industry friends here that how DRDO's culture has gone in over the years. So look at the graph. Somewhere around 1990s, when we were developing initially Indra radar or Rajendra radar for Akash weapon systems, probably DRDO was contributing 80 to 90% of the realization of the radar, and industries were hardly about 10 to 20% that time. Those days, industries are not matured to take up such kind of complex technologies. But as the time has advances, whether you're BFSR, Rohini, Revati, WLR, LRTR, MPR, Aswini, you are seeing the graph. The DRDO graph is falling. By saying so, what I mean to cover here is DRDO contributions so far as making the radar is gradually reducing, and industry contribution over the years is increasing. This is a great sign for the country. DRDO has become an enabler of industries. DRDO has become such that what we are able to do, we are leaving it all to the industries. And look at this interesting feature. Somewhere now in 25 to 30, we are going to be 100% leaving it to the industries, and DRDO is changing its gear, whether to go for photonics radar, cognitive radar, quantum radars, so on and so forth. So that's one small slide through which I wanted to give you a feeling that how the DRDO culture is going forward, pro-industry enabling. Same is the story for EW systems, friends. You all are aware of R118, DR118, all those things how we have gone in D29, DZAC, and finally into LCA Mark II and AMCA. The whole series of EW journey has gone in. And there also, if you look at the technology, if you talk about RWR, radar warning receivers, this is how the technology has grown. Like few minutes back I said, unless we grow in technology, we can't be world number one. It is not that a proven system works forever, it will continue to work forever. The user is going to throw it out unless the flavor of the current generation technology is there, because as I told you a few minutes back, the war is going to be the technology versus technology, not versus weapon. So we have to look forward to what is the best of the technologies which DRDO is growing up to. You see, right from 80s to 90s to 2000, if you look at RWR, and today we have almost gone to wide open digital RWR and HPOI digital RWR. Same is the story for the jammer. We have gone ahead from S to KU band, TWT technology, and today we are at the tile-based TR units. That's the kind of composition, that's the kind of compactness onto which we have gone forward. Same is the story of cooling systems. We are all importing it. RAM air-based evaporative cooling system is what earlier we were doing, then liquid cooling system. Today we are in ACM, air cycle machines. This has already been proven, tested, flown and getting integrated. Then biphasal cooling, and then vapor cycle machine. I think all these will be required for Su-30 and upgrades. Because these are the components, the faster they mature, the faster is going to be our aircraft empowered in the sky. So this is all going to the modern EW suite compositions with ASPJ pods, with all the technology of ATRU, DRFM, cooling, ERP, which I spoke to you just now. So these are all our approach challenges for EW systems. And third one comes us to be IRST. Like I said, passive is going to be the winner in the sky, because as much you radiate, you expose yourself. By saying so, I must confess to you that IRST, infrared search and track, these critical technologies we have achieved quite a lot today, and we are now systems are getting ready to be integrated and flying in the sky. It's a huge technology change again, whether you talk about derotation, we talk about deblooming, you talk about image processing applications, FSMs, servo controls, whatnot. A set of technologies, this has been developed. And the next one comes out to missile approach warning systems, because they have to work in tandem. Like I said, IRST and missile approach warning system, the moment together they mature, they become really an invincible passive force in the sky. And that is what will be the path laid for distributed aperture systems. So these are all the same story here, how we do through the design and how we through the qualifications. A number of payloads have been realized in the labs through that. We have our own challenges when you talk about camera, when you talk about class, different varieties of electro-optical systems which has been developed by the labs. Now come to the last one, is the communication. Like I said a few minutes back, unless we are 1 minute, if your mobile is not having your data circuits or the networks, we go mad, right? When it is a peaceful, simple saying a hello to your friend. Imagine if the communication system does not work to the level, what happens to the fighter in the sky? What happens to the pilot inside the fighter? That's the criticality of communications. And so much of the data we are thinking, so much of the video, remote operation. I spoke a few minutes back about unmanned fighters. All this can work where we have got the most reliable, wide bandwidth, encrypted, below the noise level, signal extraction level, cognitive communication systems. And that's what exactly we are looking forward to, whether we talk about SDR, we talk about data links, we talk about SATCOM terminals, all of them together are going to show you what is going to be the current trends of the systems. So this is what is the field of developments which has already been done, whether it's about SDR, handheld, fighter aircrafts, SDR, SATCOM, blast tropo links, VLF and whatnot. So these are all the concepts of software-defined radio. It's a great architecture we are building now. Like a few minutes back, Semilak was talking about standards. Today, lot of SDRs we import, lot of SDRs we design, lot of our industries make SDRs, our DRDO makes SDR. It's all fine. Like so many computers are there. Whether IBM makes or HP makes or anybody makes. But as long as the window is there inside, it works. All of us are happy to take it. So we are looking forward to a unified operating system, a unified standard, so that we have absolute flexibility for the hardware wherever you want, but let's have a set of unified waveforms to make our SDRs interoperable, to make our SDR powerful, and make our development cycles much faster. So friends, this is the document which I will skip thanks to Semilak. I thought since it is the entire conference is and test methodology, I should touch upon a little bit about it. But having said so, one point I attempt to speak. All along, our designers look up to QR. I have said to my designers now, I have spoiled them thoroughly that design systems without QR. Because the moment you look at the QR and the design, your whole concept gets restricted and limited to who sets the limits for you. Time has gone that Indians have to put their own limit, Indians have to draw their own targets, and Indians have to put all out effort to reach their own targets. So that's one part. But at looking at the augmentations of the system, acquisitions of the systems, the users always will require what they want. So there has to be a question pattern. I am only saying a QR alone does not work. Let's have a concept that QR and ConOps, together we should take it before we take the systems to the designer's desk. Otherwise, what happens? You make a system with QR, you make a beautiful radar, you have absolutely no idea on the side there has to be EW system who is the first fellow to jam the radar. Or you are targeting for a missile which has got a seeker which operates in the same band where the radar is operating on. So all these complex systems to handle at the latter becomes much difficult. Interoperability, the scenario of operation, the attack mode, coexistence, maintainability. Let's address all this holistically in the country at one level, and that's probably what we thought more to stress upon concept of operations. Beyond that, I will not touch upon because he has made my job very, very simple. Test and methodology is how we do. With due liberty, I would like to skip them. If somebody is interested, you can share the slides. This is what is the examples I was saying, how much time we take. This is how the time grows. I think similar graph he has already shown. This is how the entire facilities has to happen. And these are the total project scenarios we are going to do about. Friends, all these I will try to skip but with the necessity that India definitely needs today to have a great laboratory across the country to convert my basic statement which I said from developer to deliverables. To address that, we need to have testing stage and flight evaluation stage. So friends, these are all the test facilities for communications required. As a labs of all my sensors, I have created a committee, and that committee has come out with a beautiful report 3 days back addressing integrated way. See, another thing happening, all said and done, Indian economy, any economy for that matter, we can't have a replication and duplications. We should really organize our test rigs in such a uniform way that every sensor works there. It saves money, and more than that, it proves interoperability. It proves working in cohesion, working in coherence and codomain. So that's the reason this team is doing up, and this is the graph I really liked. I got it from somewhere through my committee's review, that if you have only modeling simulations, if these are the number of trials required, if you go to system integration laboratory, it's come down. If you go to Hills facility, number of actual trial comes down to 50%. And if you go to installed system test facility, 40%. Open air ranges to 30%. That's the kind of a thing which is required. So more testing facilities you have, that much the facilities required for the flying gets reduced. So this has been the journey which I was trying to show you up. I'll just give a glimpse of few of the future technologies. Yes, definitely, because that is one of the domains they asked me to speak upon. Multi-dynamic MIMO radar and the synthetic aperture radar and a very high-speed image processing algorithms in radar. This is what we are looking it up to. Cognitive, fully adaptive radar for overall improved performance, STAP, airborne multistatic radars, drone configurable phased array radar, very, very interesting configurations. Each one of them is a drone, and they are all going to carry the TR modules, and they are going to reconfigure themselves dynamically. That entire aperture remains under the designer's control even while you are in operation. That's the kind of a technology which our lab is working up to. EW systems similarly with the tile-based architecture, AI/ML framework which is very strongly required for EW systems. Antenna array in Ka-band, digital beam forming. Radome is a very, very important area again. I think day in and day out we talk about that multi-stream radomes, single-stream radomes and all that. Thermal technologies, I said already, vapor compression and all that. Electro-optics. Common aperture optics, this is a very, very important technology. You will be very happy to know that the lab has already developed, and the first module we are flying in Shane in Dornier, wherein because every fellow was asking me, they require one band of the camera. One fellow wants a IR camera in mid-wave, one in short wave, he also wants in HD, he also wants in a high-speed camera. If you add all of them, but he wants it at 450 mm dia, 45 kg. How does it work? So we thought we will combine all of them to one single lens, and we get the signatures through the single lens, put the respective beam splitters, divide all the beams separately and put the detectors optimized so that it becomes a compact. As an outcome you get all the images. This is a very simple concept to listen, but a very, very tough design to achieve it. This has been done, and today we have got one of the ultra compact sensor addressing all the bands through a single window. That's called the common aperture optics. In the similar way, I have given a challenge to my RF guys. So many antennas are coming today. Radar is having antenna, EW system is having antenna, communication is having antenna. Can we use the same antenna for all the purpose? That's what is the great concept called share aperture. And that's what the team is working across, and very aggressively the work is going on. So similarly, just I will conclude with this couple of slides. What is the fighter next? As I said, unmanned technologies, I have covered this. Artificial intelligence, smart structure and the hybrid systems, network-centric payload processing, passive aeroelastic tailored, this is a material, that's the next generation composite which we talk about, hybrid sensors and improving human-machine interface using data analysis and biomimicry, nanomaterial systems, hypersonic aircrafts, next generation electronic attack, cyber attack, and the most important here, directed energy weapon. This is something which is fighter is going to be empowered with. Whether you talk about laser based, whether you talk about microwave based, we have to go for beyond missiles, this kind of directed energy weapon to empower our fighters. Then only you will have an infinite carrying capacity. You can keep on firing as many you want. You can neutralize as many you want. What we saw probably in our mythological stories is going to be the reality in the blue sky soon. Lots of work is going on. Today's time is not enough. Some other day we'll talk about what is our technology progress in directed energy weapon in the sky. Friends, that is why I wanted to conclude. But I wanted to conclude with one simple statement. We are incomplete without you. The reason is very simple. There are so many sponsors here. Some of the wonderful sponsors, they have worked with me before also. Industry is the heart of India today. Due to paucity of time, I couldn't make that slide, but if you permit, if I remember, I will analyze that. Somewhere I spoke this. India, how does India stand for? I stands for industries. N stands for nascent forces. When I say nascent forces, it is the startups and MSMEs. You all are going to be the future leaders of this country. You all are going to dictate where the India is going to be the world leader in economy. You all are going to realize the technology which I'm dreaming and show you in the sky today. So N stands for the nascent forces. D stands for DRDO. We are there with you and we will continue to be with you. And I stands for incubation centers which grow inside our academia to turn every dream to reality. And the A stands for academia. These are the 5 forces together which is going to make India the world #1 and make our entire firepower, all our armed forces, the most invincible one in the sky. Thank you so much for the patient listening, and thank you so much for believing us that we can deliver the best in the world. God bless you all the very best. Thank you. Namaskar.